refers to processors from Intel, AMD, and VIA. Intel takes about 80% of the PC market, and ARM takes about 20%.
Okay, thanks. I forgot to press the button, record button. Okay. So what is x86? Probably you have heard that terminology a lot, x86. Okay, that term is used to talk about the processors from Intel and AMD. Okay, so if you look at the previous slide, so the processor from Intel, right? AMD, we don't use that name, right? In the past, the brand name is 286, 386, 486, and so on. Something 86, right? And nowadays, Intel processor brand name is Core i3, Core i5, Core i7, or Core i9, right? We no longer, Intel is not using that convention, this convention anymore. But because of that historical reason, people use x86 to refer to a processor from Intel and AMD. Okay, probably I have to remove this one. Intel is doing, very well these days. Sorry, not Intel. AMD is doing, very well. So that statistics, I think, is no longer true. Okay. Apple is also using Intel CPU, Intel processor in their product. The chipset, probably we can just read and move on. This one, Juan, can you please?
We call North and South bridges as chipset. Chipset has many PCI devices inside. North bridge. Should I read that? Memory controller, PCI Express ports to connect graphics card.
Okay.
South bridge, HDD controller, USB controller, various peripherals connected, PCI Express ports. Note that the landscape is being changed. For example, memory controller is integrated into CPU.
Okay, chipset, right? That this one, CPU. Okay, two chipset, right? North bridge and South bridge. Right? I'm not sure that link is still live. Let me check this. Oh, still live. Okay, so look at this. 437 pages. Pretty old, 2007. Right? So it is explaining operation of that chipset. Right? Chipset. So pretty, lengthy document. Right? CPU, then North bridge, South bridge, main memory is connected here, graphics card connected here, and so on. Right? So that is, and some detailed explanation about that internal. Okay, internal. So North bridge, it has memory controller hardware inside. To access main memory, you need memory controller. So main memory, right? DRAM based, the chip. To read from memory, write to memory, you need some hardware support. That is called memory controller. So CPU generate read transaction. So if you have taken my course, RISC-V, right? LW instruction or SW instruction, memory read and memory write. You are writing some data to memory. You're reading some data. So CPU execute those instructions, and that goes to memory controller. Memory controller. And main memory here. Main memory, right? So that is generating actual transaction to access this main memory, okay? And give you some data, write some data. Okay, some brief explanation. Let's move on. So that is PCI Express, PCI and PCI Express, slot. Okay, very old PCI slot and PCI Express. So pretty old computer system. Okay, here that is PCI Express slot. Okay, CPU goes to here, and main memory goes to this yellow and black. Okay, and chipset, this one. Okay, let's just skip this part. Okay, how about a smartphone world? Smartphone, still, computer system, meaning it has CPU, memory, and I/O devices. Okay, so look at this, the product. This product, Apple introduced to the market, June 2008, June 2009, June 2010, October 2011. Some hiccup, right? Then September. So what happened during this time? Remember? Steve Jobs passed away. Right? Steve Jobs passed away. So there's a hiccup, then they back up a little bit. So September, October to September. So every September, Apple is rolling out a new iPhone. Okay. Galaxy. This. June, May, April, March. Right. So Samsung is pushing their employees very hard, right, to reduce time to market. Okay. 12 months to 11 months. Okay. So 11 months, skip 11 months. So 1 month, earlier. So every March or February, Samsung is introducing new phone. Okay. Let's take a look at inside of iPhone and Galaxy. Right. I'm trying to explain this one. Okay. CPU, memory, I/O devices. It is very complicated, but those parts are either CPU or memory I/O devices. Okay. So look at this. This one is called application processor. So inside the application processor, you have ARM CPU. Okay, designed by Apple, manufactured by Samsung. Pretty old, iPhone, 2010. Then here, main memory, 512 megabyte main memory. And the other component, the other chips are all I/O devices. Okay. iPhone 4, you have some sensors. Ji-hoon, can you please read?
From accelerometer. Accelerometer detects when the user has rotated the device from portrait to landscape, then automatically changes the contents of the display accordingly. Proximity sensor detects when you lift iPhone to your ear and immediately turns off the display to save power and prevent inadvertent touches on the iPhone is moved away. Ambient light sensor automatically adjusts the display's brightness to the appropriate level for the current ambient light, enhancing the user experience and saving power at the same time.
Okay, there are some sensors integrated in smartphone. The first one is accelerometer. So you have a smartphone, right? If you rotate your phone like this, Then accelerometer is detecting your movement and change the screen from portrait to landscape automatically. So the sensor is detecting your movement. Proximity sensor. So when you take a phone call like this, take a phone call, the proximity sensor, this one, sensor is detecting, measuring the distance between your face and the phone. If that is close enough, it is turning off the screen, right? You're not looking at the screen, right? To save power, okay, to save power, it is turning off the screen, right? Then ambient light sensor. Ambient light sensor is detecting the brightness of this, your environment. So for example, if you go to a movie theater, dark place, the screen doesn't have to be that bright. So it dims the screen to save power. So many sensors integrated inside smartphone, and those are also I/O devices, sensors. Okay, sensors are I/O devices. Okay, another example, iPhone 5 here, application processor. Okay, still ARM CPU inside, and one special thing about this chip is main memory. 1 GB main memory is also integrated inside that chip. So here, CPU, main memory inside one chip. Okay, if you go back, so here, CPU, main memory is separated here, physically separated, but now one chip, right? CPU, main memory. All other devices are I/O, right? Accelerometer, sensor, touch screen controller, Wi-Fi module, gyroscope, everything is I/O device. Okay, so computer system, CPU, memory, I/O devices. iPhone 7, right? Same message. A10, okay, ARM CPU and 2 GB main memory integrated together inside one chip. Okay, so CPU, memory, all I/O devices. Okay, Galaxy, same thing goes to Galaxy. Okay, so you have application processor called Exynos. That is their brand name. Exynos, right? Application processor. Okay, here you have ARM CPU and 1 GB main memory together. Okay, and I/O devices. And if you open this, then this one is a block diagram. Exynos application processor. So you have 4 ARM CPUs, and main memory, right? 1 gigabyte, I think, right? 8 gigabit, right? So 1 gigabyte main memory, okay? And these boxes, okay? The sky blue boxes, okay? All I/O devices, okay? Timer, JTAG, LCD, HDMI, I2C, UART, I2S, SPI, all I/O devices. Okay. Galaxy S4, same message. Okay, take a look at just to match. Okay, this yellow, okay, and green. Read this. Okay, same thing. Galaxy S8 in 2017. Snapdragon application processor from Qualcomm, and 4 gigabyte main memory integrated together. Main memory size is getting bigger and bigger, right? Okay, this one is our experiment environment. That is probably most important to you. That board will be given to you, okay, after registration is finalized, probably next week. Okay, so everyone, each and every one of you will get one board. but you have to return back after semester. Okay. So here, at the center of that Z board, we have device called Zinc 7000. It has two CPUs, two ARM CPUs inside. We are going to use one CPU, okay, one ARM CPU in this class. Okay, and main memory here, 12 megabyte main memory. Okay, on board, and all different I/O devices. We have simple I/O devices like switch, right, and LED here. 1, 2, 3, 4, 5, 6, 7, 8 LEDs. Okay, right above that switch, this one, and push button. Okay, simple I/O devices. Okay, you can take input from this switch. Okay, this ARM CPU can take input from switch, and also, turn on, turn on those LED. Okay, turn on those LED with the program. Okay, and then you can send some message from ARM CPU to your PC. You can send some message. That cable is connected to your notebook computer. Okay, this cable, notebook computer. So you can send some message to your PC, and your PC can send some message to that ARM CPU through this UART, serial communication. Okay, port, UART, serial communication. So on the flip side of that board, we have a clock oscillator mounted, 33 megahertz clock, okay, and 100 megahertz clock, okay. But don't worry too much about this, clock. Okay, we are going to use anyway this, first clock. Okay. So that is internal block diagram of internal block diagram of Zinc 7000 device. This one. Okay. So here, Zinc 7000. Zinc is composed of two, big parts, PS and PL. Processing system and programmable logic. Here. So PS, processing system, and that is a block diagram. This one. It is PS, right? PS, processing system. Okay. And this yellow box, there is a programmable logic PL. Okay. This one. This gray area, PL. I'm not sure how many of you have heard about this terminology, FPGA. That is field programmable gate array. So PL is actually this one. It's PL is FPGA, meaning that you can design your custom hardware with your computer, with your notebook computer, and you can download your custom hardware to that PL section. This, sky blue dot, that is custom logic. Someone designed a custom logic and downloaded to that Zinc device. So this PS, this ARM CPU, can talk to that guy, that IO devices. Okay, but in this class, we are not going to design any hardware. You don't have to worry about this FPGA. Okay, I'm going to provide hardware system. Okay, hardware system will be provided to you, and your job is writing software using low-level language, assembly, right? Instructions. Okay, to touch those IO devices, and that IO device those IO devices and turn on LEDs and take input from switch and so on. Okay. Okay. So block diagram. Okay. So here, PS, we have two ARM CPUs. We are going to use one of them. Okay, just one. Okay, and it has internal memory called on-chip memory. It has internal memory, and we have external memory as well, DDR, right? That is external memory, right? Main memory, okay? External memory, and we have internal memory, small internal memory. And even inside the distinct device, we have some IO devices like UART, I2C, okay, USB controller, Ethernet controller. Okay, even inside the chip, we have CPU, small memory, and several IO devices. Okay, even inside the chip. Okay, so that is called system on chip, SoC. System, whole system is inside the chip. So we call that SoC. This one, SoC. Okay. Okay, objective. Last slide probably. Jion, can you please? Yu Jihyun.
Understanding of computer system through hands-on labs. Software ARM assembly programming with Cortex-A9 based system. Basic ARM programming, timer and UART programming, interrupt and exceptions programming, cache and TLB manipulation, TEE with trust zone. Hardware design and integration into Cortex-A9 based system.
Okay, thanks. You don't have to worry about the last thing. Okay, you don't have to worry about this. Only this one. But if you recall computer architecture class, we mainly talked about CPU, right? CPU and memory hierarchy. I'm very bad at spelling hierarchy. I think that is wrong. HIR. Anyway, memory hierarchy, meaning that CPU, we have cache and main memory. So in architectural class, we spent a lot of time talking about this CPU, right? We discussed single cycle CPU and pipelined CPU. Okay, so basically, how to design the CPU. Discussed two different micro architecture. Micro architecture, right? Two different micro architecture. So we spent, I think, more than 10 weeks talking about this. So before that, you studied instructions or machine code. Machine code specific CPU is providing. Okay. Last time we discussed CPU called RISC-V. Okay. So RISC-V is providing some instructions. So we studied those instructions. Then later on, talking about CPU implementation. That CPU is executing those instructions, right? And then cache organization, cache structure, right? Cache structure. That is what we have done last semester, right? And for you guys to understand computer system, you need one more thing: I/O devices. Okay, I/O devices. So this semester, we are going to use diverse, I/O devices, several I/O devices, not many actually. We are going to touch timer, UART, and GPIO. These three simple I/O devices. Okay, simple I/O devices in this class. And before that, because we are using a new CPU, not RISC-V CPU, we are using ARM CPU. Okay, we are going to study instructions. Instructions ARM CPU is providing. Okay, what kind of instructions ARM CPU is providing? Okay, essentially three categories of instructions. If you remember the lecture last time, three categories, right? Data processing instructions, memory access instructions, and branch instructions. We'll talk about these three categories of instructions ARM CPU is providing. Then we will talk about these I/O devices. Okay, basic ARM programming using instructions, then I/O device manipulation, and interrupt exception. What is that? What does that mean? Interrupt exception. So we have CPU and memory is connected, right? Like this. And we have I/O devices, right? Timer, UART. Okay. And those devices are somehow connected to CPU, right? Through some bus. I'm very bad at this drawing. So like this, connected. Okay. Then interrupt. Interrupt is a mechanism. Mechanism for communication between CPU and these I/O devices. Some event happens, then this I/O device timer wants CPU to know. Okay, some event happens. Okay, I have some event happens. Okay, so that event is notified through some special connection that is called interrupt. You want to interrupt the CPU for your handling of your urgent task. Okay, so interrupt is very fundamental, very important mechanism for communication between CPU and I/O devices. So that will be discussed. And also exception. Exception will be what do you mean by exception, right? So one example is what? What if CPU takes undefined instruction? Okay, CPU read the instruction from memory, some instruction from memory, then try to execute it. But CPU does not know that instruction. Some bad hacker modified that instruction. 01010. That is instruction, but change that bit to 0. So CPU read that instruction, then turns out that, okay, so I don't know that instruction. Then what should happen? That is called undefined instruction. Exception. Undefined instruction. Okay, so exceptional case. Some exceptional case happens, then what should happen? So interrupt exception programming, and cache and TLB manipulation also. Cache manipulation, TLB manipulation. So last time in computer architecture class, we didn't have enough time to talk about this TLB. TLB is very important hardware component. Very important hardware component inside processor. Okay, we have some TLB component. That hardware is there to support virtual memory. Okay, virtual memory. So inside processor, we have other component called TLB, translation look aside buffer. Okay, to support virtual memory. So last time we didn't have time. So hopefully this semester, so I'm going to explain why TLB is necessary inside our processor and how to manipulate the TLB with your program. Okay, that will be discussed. The last thing is called TEE, Trusted Execution Environment. These days, security, right? Security is very important, right? Some bad people are trying to attack your computer. Okay, so to prevent that from happening, CPU vendors are providing very special feature, security feature. Okay, ARM is providing a hardware technology called Trust Zone for security, and Intel is providing technique called SGX, software guarded extension. Okay. So we will talk about trust zone in this class. Okay, so those are rough 5 topics we will study in this class. Okay, grading policy. 2 exams, a midterm, final. Midterm is taking 30% and 40% final. There will be many assignment. Okay, roughly 1 assignment every week. Okay, 1 assignment every week. That will take 30%. And there is a small mini project, and that is for your extra credit. If you combine these two, exam, assignment, 70, 30, 100%. So that is extra credit, 10% extra. Okay, so small mini project. And I'm going to ask you to design super simple operating system. Okay, super simple, really super simple operating system to run 3 different tasks. You have 3 different tasks to run. Okay, so design operating system, small, tiny operating system to run these 3 tasks in the round robin fashion. Okay, that is the one. Okay, make sure you attend the class, otherwise fail F, right? Okay, that is the one. Any question? By the way, I already posted the first assignment here. Okay, first assignment is easy. The lab environment setup. Okay, environment setup, experiment environment setup. So just follow. So here. So follow this instruction until page 22. So go back, this one, lab setup instruction. Until page 22. The reason why I stop here, because you need this hardware system. Okay, so that will be given to you again next week after registration is finalized. So I'm asking you to install the tool, the CAD tool. For software development, CAD tool, computer aided design, CAD tool called Vivado. Because we are using Zinc 7000 to use that device, we need the environment this company is providing. Okay, so if you Google search Xilinx Vivado ML edition standard. Okay, then this one. Okay, this one. I'm asking you to install this tool. Okay, Vivado ML standard edition, which is free. Okay, free version. Okay, enterprise version you have to pay $3,000. Pretty expensive, right? So click on this. Okay, then we are going to use this version 21.1. Okay, 21.1. Scroll it down. Depending on the operating system of your computer. If you use Windows, then use this one. Windows and Linux, this one. And unfortunately, there is no iOS version. So if you use Mac, Apple computer, then you probably, so what is the option, someone? You have to use some emulator or something?
Maybe that is the best way, I think, also.
Dual boot, probably, make your machine dual boot, right? Then install Windows or Linux, right? So here, Windows and Linux. And one thing you have to be careful is this one. Warning, okay? One thing, warning. You need at least 100 gigabyte space for installation. It's a huge, huge software. So you have to make sure you need that 1 gigabyte disk space, okay, available. Okay, any question about the class? Yes, yes. The video will be uploaded to actually YouTube, not Blackboard. Okay, so yeah, so that will be more convenient to you, right? But the problem is, I press the button, record button in the middle of this class. So I think only 30 minutes video, the later part will be available for today's class. Okay. Attendance is recorded. Yeah, attendance will be recorded automatically, right? You log on to the machine, log on to Blackboard, right? And click on Zoom, then your attendance is recorded automatically, right? Any other questions? So far, 43 students registered for this class. I think that is the right size. Okay, right size. Not too many, not too small. Yeah, that is good size. Okay, if you don't have any question, I guess that's it for today.
Thank you very much.
Yes, bye. See you next time. Bye.